And we are now recording for all of those people here.
All right, so I guess since Ellen, you're the only person here, could you maybe give me just a bit of background about kind of where you stand in terms of computer programming?
Very little. I am of the older generation. I did learn a lot during the pandemic. I am the hover queen of teaching. I can use that the hover camera really, really well. Mm-hmm. Currently this year, I just started teaching STEM. So I'm teaching to 3rd through 5th graders some STEM, and then the kindergarten through 2nd graders, they just get a taste of it. So I'm trying to learn a little bit about coding programs to see if this would be something that I could introduce to the children.
Sure, yeah, for sure. I think we can certainly kind of get you pointed in the right direction for that. And so, like, in terms of what you've done before, like what platforms or tools have you been using so far?
With regard to coding or STEM or?
Just coding in particular.
I was part, it was a few years ago, of the Amazon, I'm trying to think of the name of it, Scratch?
Right. Yeah, Scratch is a very popular platform for kind of introducing people to coding basics.
I used that. I was in it for a year, and then my principal went ahead after telling me I'd only be teaching science. He pulled the rug out from under me and told me I'd be teaching math and science. And I know how that goes here. So math takes, precedence over science. So I basically told the Amazon program I could no longer participate in the Scratch program. So I had to give it up.
Gotcha. Okay.
Yeah. Other than that, I've tried to do like Codable. I've gotten on it and I've tried to play with it, but I guess I don't know if it's just me. I'm not very computer smart, to be honest. And some of the things I look at, I'm like, I have no idea how to do this and how they're getting the answer and how they're moving the object and it's giving them what they want. The kids do better than I do. When I did the Scratch and I introduced it to some of my students, and this was during the pandemic, I believe, they did better than I did. They did well. I can do it if somebody's there and I'm practicing, but I must admit, if I don't touch it for a while and I'm not on it for a while, I forget.
Right. And yeah, that's certainly understandable. There's a ton of stuff out there, and it's like, no one person can, remember all of that from memory, right? So I guess one thing I would like to say is I think one important mindset to keep in mind when it comes to just programming and coding in general is never be afraid to just experiment with it. Like there's a very small chance that you're going to break anything. So just feel free to, go crazy. Just try stuff, see what works, see what doesn't. And a lot of the times these introductory environments will try to help you out with like, okay, you got something wrong here. That doesn't work quite the same way. But yeah, I mean, experimentation, I think, is something that's worthy of pursuing.
Okay.
And I think Alistair was asking in the chat, so where do you teach?
Oh, where do I teach?
Mm-hmm.
Oh, I'm at Raleigh Bartlett Meadows Elementary School. I've been here for 27 years.
Awesome. Wow. Okay.
Yeah, creature of habit. So yeah, I've had the children, I've had their parents.
Wow.
So it's amazing when they come in and say, I had you in 3rd grade, I had you in 4th grade. And Yep.
Yeah, so I've been at the University of Memphis for, I think this is my 15th or 16th year now. So I can't say that I've taught anyone's parents yet, but I might be there in the near future.
It's coming, let me tell you.
Yes, I mean, that's me, by the way. So my name is Top Malastri. I've been with the computer science department at U of M for, again, about 15 or 16 years now. Mm-hmm. That is a pretty old picture of me. I actually have a lot more hair than that now. I'm trying to defy time. But yeah, I still look not that different, I don't think.
And I gave up, and now I'm totally white and gray haired. The pandemic did me in, and I said, I'm over it. So I just gave in and said, there you go. This is it.
Yeah, so what I had in mind was, are you familiar with Khan Academy, this website?
I have used it before. It's been a while, but I have used it before for math.
Awesome. Yeah. So I think they probably got started with math, I think, but they've since spread to a lot of other areas as well, including programming. And they have this nice environment on there where you can do a bunch of like interactive programming things. And I wanted to just kind of show you some things you can do with that environment.
Okay.
So yeah, I mean, if you'd like to follow along, then you are more than welcome to. But I think this is all going to be, recorded and accessible after the fact as well. So no need to follow exactly what I'm doing here.
Okay.
But if you go to the Khan Academy website here, just khanacademy.org, going to the courses section up here should bring up like a complete list of all of their offerings. And there should be a section for computing, which is a bit smaller than the others, but there's a lot of good stuff in here. And so I want to focus on just this very first thing here, the computer programming portion.
Okay.
So yeah, clicking on that is going to bring me to this whole section here with a bunch of different subsections and so on. What I want to do for now is actually, let me just go to the bottom here. And there should be this section to just create a new program. And we're just going to go straight to this new JavaScript program thing right here that kind of just sets up a blank canvas for us. And so what this is there's a section on the left here where I can type in a bunch of code. And I can immediately see what's going to happen with that code here on the right. And the nice thing about the way this is set up is there's a nice reference down here as well for like all the various commands that are available to you. And this is a very like visually oriented thing. So I think it's a great tool to introduce students to coding without being too overwhelming. They're actually writing code still, but they're seeing like very graphically how that code gets rendered on the screen. So let me just try a few things here. If I look at, say, this very first command, RECT, right, rect, that's supposed to draw a rectangle somewhere. So let me just try typing in like RECT here. And is that like, is that size okay, by the way? Is that like legible on the screen share?
You can read it. It's a little small.
Yeah, let me see if I can blow this up a bit. How about that? Is that a bit better?
That's better, yeah.
Awesome. Okay. So yeah, this RECT command, if you look at the reference down here, it kind of gives you some clues as to what this extra information in parentheses is supposed to be. But if you want to get more details on that, you can just click on this link. And that'll actually open up a new window that kind of demonstrates what all those things do. So like this example says, if you give it this RECT, this rect command, with these four numbers, 100, 150, 200, 100, it says it's going to draw a rectangle at this point. That's like an XY coordinate, basically, with a width of 200 and a height of 100. And then you can see like over here on the right-hand side, exactly what effect that has, right? So let me just try putting in my own numbers. I'm going to go back to my, my own canvas here. We had these four numbers. The first two were the X and the Y coordinates. Let me just try something like maybe 50 and 100. So that's 50 on X and 100 on Y. We then need to follow that with the width and the height. And these are all measured in pixels, by the way. So let me try something like, how about 250 and 100 perhaps? And there's one more thing that has to end this line. This is something that you'll see often in many programming languages, which is a semicolon. So that's kind of the way that the computer tells that you've reached the end of that line. And you can see as soon as I typed in that semicolon, that rectangle immediately appeared on this canvas on the right. So yeah, you're seeing some immediate feedback from like, the effect of that command. So yeah, there's our rectangle. The upper left-hand corner is at that 50, 100 point. And by the way, I believe these points are measured from the upper left. That's kind of a common thing when it comes to graphics. So it's like 50 to the right and then 100 down is what that means, 50, 100. And then the width here is 250. The height is going to be 100 pixels. So let me try a few other things here. We can do like ellipses maybe. That kind of has the same setup with the XY coordinates and then the width and the height. The command for that was just ellipse. So I'll just put ellipse right here, followed by some parentheses. Let me put this at maybe, how about 200, 100? And then the width and the height, let me make those the same actually and see what happens there. I'll go with maybe 75 on both. And then once again, I'm going to end this with that semicolon at the end. And yeah, as you can see, there is that ellipse that just got drawn on my canvas. So I believe the 200 and 100 here, it looks like they refer to the center of that ellipse. You know, the center right here is like 200 over and then 100 down. And then these 275s refer to, again, just how wide and how tall that is. And because they are the same at the moment, that got rendered just as a circle. And if I change these, it should actually update in real time as well. So let's say I make the width like 100 instead of 75. You can see it's kind of gotten squished out horizontally. If I were to replace that second 75 with 100, it kind of gets squished vertically. So yeah, we can just kind of play with those numbers there to make this look however we want it to look. All right, so yeah, is that all making sense so far for everyone in the audience? See, we have 2 new people. So welcome, Marion and Lavita, is it? Hey, glad to have you here.
Yes, that's correct.
Awesome. So yeah, everyone with me there so far with what this is doing?
Yes, sorry.
Yeah, no worries. All right, awesome. So what else can we do with this environment? We can actually add some color to this as well. So let me see if I can find this in the documentation. Yeah, here we go. So this is a little bit further down in the documentation, but we can set what's called the fill color for our shape. Are y'all familiar with like the red, green, blue representation of colors in a computer?
No.
Yeah, so let me say a few words about that. There's a bunch of different ways that colors can be stored digitally. The so-called RGB representation, red, green, blue, that's one of the more common ways out there. And essentially all it says is we can represent pretty much any color we want using some combination of red, green, and blue. And then usually when we talk about RGB, the values of each one of those components is going to range from 0 at a low to a high of 255. And so like, for example, if we're talking about just pure red, that would be red 255, and there'd be no green in there. So green would be 0, and then blue would be 0 as well. And I'm typing that into the chat as well. So we have some kind of written reference there. But yeah, so like that's really all this RGB means. We can generate any color we want just by mixing red, green, and blue. Now, there's some nice web resources that will let you do experiments with this kind of thing. Like if you just Google color picker, I think might be a good way to find something like this. Hey, how about this? Google actually has one built into it. So if I specify like a certain set of red, green, blue values, like down here, let me try that 255 red, 0 green, 0 blue. You can see that corresponds to like pure red. If I mix, say, red and blue, let me leave red at 255. Let me leave green at 0. And then let me change this blue to 255. You see that becomes purple, which is like a mix of red and blue. And let me try a few other things here. It turns out that if all 3 of these are the same, let me try like 40, 40, 40, for example. What that corresponds to is like a shade of gray, essentially. And the lower those numbers are, the darker it's going to be. The closer to 255 they are, the higher they are, the lighter it's going to be. So if I try, say, let me try like 180, 180, 180, maybe. What you should see happening here is, yeah, that is a much lighter shade of gray. So yeah, the takeaway from all of this is really just that you can generate any color you want by combining red, green, and blue components. And that is a very common way to represent colors in a computer. And so, yeah, if I want to use this fill thing, what fill requires from me is just the values of those 3 things. You know, how much red, how much green, how much blue. Let me try putting this fill up here. And you can see here that it actually gives me this pop-up thing as well. So I don't have to memorize all these numbers if I don't want to. I can just use this palette here to select whatever color I want. I'm feeling like, how about some purple right now? So yeah, that shade of purple turns out to be this particular combination of red, green, and blue. Now, one thing that you've probably noticed is even though I do have this fill line inside my code, none of my shapes are actually purple at the moment, right? And the reason for that is fill needs to be set before I tell it to draw whatever shape in that color. So let me do this. Let me just move this line 3 to somewhere above these previous 2 lines. I can just do some cut and paste here. So right-click cut, or as a lazy computer programmer, I like to use keyboard shortcuts. So Control X will cut that out. I can then paste that Control V up here. And we can see now that the ellipse is being drawn in that purple shade that we just specified from fill. And if I were to move this even earlier, like before rect, you can see now that both of them are being drawn in purple. So yeah, that just kind of sets what the current fill color is, and that will remain active for whichever commands follow that fill. So let me try doing this maybe. Let me try making those 2 shapes, like choose different colors. I'm going to put another fill command right here before ellipse. Let's pick something different here. I might try, how about green? So that looks pretty good. And yeah, so we now see that the ellipse is in green because that was immediately preceded by that green fill. But the rectangle is still in purple since that first fill was purple. So yeah, we can actually change the colors of all the shapes on the screen as well. So let me attempt to draw something here, all right? I'm not the greatest artist in the world by any stretch, but I'm going to try to do something here. Let me just try to draw a very basic depiction of a car, maybe. And it's going to just be like 2 rectangles and 2 ellipses. I want like 2 ellipses to represent the wheels. Maybe a couple of rectangles to kind of build the basic shape of the car. And so let me see, what should we do with this existing ellipse here? I think I want to move that one down a bit, right? Because right now it's kind of on top of this rectangle. If I want to move it down, that requires that I mess with this y coordinate. And remember, I was saying earlier that in a graphics program like this, usually positive y means you're actually going down. So I actually want to increase this 100 here. Let me put this up to say 150, see what that does. You can see that's already moving it down a bit. Let me try putting that to 200. And yeah, that's a bit closer to the position of a wheel. Let me also make this the same on both the width and the height. And let me also maybe kind of mess with these x coordinates a bit. I'm going to shift this to the left, which means I need to decrease that 200. So yeah, here is my first wheel. Let me then copy and paste that ellipse command. I want a second ellipse now. And I want this one to be a little bit further on the x-axis, right? So let me pump this up by about, I'm going to guesstimate about 150 or so. So let's put that up by 250. And yeah, that seemed to work out pretty well. All right, so yeah, that's kind of a nice way too to introduce students to just thinking spatially. You know, this is the x coordinate, this is the y coordinate. You can make changes to these and immediately see the results show up over here. All right, I feel like my car should have not green wheels. So let me change this fill right here to something a bit more realistic. How about like a dark gray, perhaps? So yeah, there is my wheels of the car. My body of the car, we have this rectangle going on right now. I feel like that's maybe a little bit tall. So let me modify this height right here to be a little bit smaller. I might do with 80. And let me also shift this y coordinate down just a little bit. How about 120? There we go. So there is a very basic looking car. And then if I wanted to, I might add like another rectangle to represent like the, the passenger compartment or whatever. Let me see if I can do that right here. I want to say 100. How about 120 again. And then I want this one to be a little bit not quite as wide as my existing rectangle. So I'll try maybe like 175 here. And height, I'll do maybe 50. Let's see how this looks. All right, so that's not quite where I want it. I want this to move up a bit more, right? So I can decrease this Y right here by 60, try 80 maybe. How about 70? And yeah, there we go. So that's doesn't look great, but it's kind of passable as a car from the side. All right, so we now have all of this right here. So suppose what I want to do now is I want to move this whole thing to the right. So like one way I could do that is I could just look at all the X coordinates in all four of these shapes, right? You know, right now, this first rectangle is starting from an X position of 50. The second one is starting from this X position of 100. And then similar things happening here for my two ellipses. So yeah, I mean, one way I could do this is I could just say, if I want to move this, say, 50 to the right, that means I want to add 50 to all four of these X coordinates, right? So like 50 plus 50 here would be 100. 50 plus this 100 would be 150. 50 plus this 100 would be another 150. And then 50 plus this would be 300. And then so now everything has been shifted over 50 pixels to the right. But I want to show you one more convenient way that I could accomplish that same thing. Let me introduce what's known as a variable at the very beginning of this whole sequence of code. And the way that's going to look is I'm going to tell my program I want to make a variable. So this keyword var just means let's make a variable. I'm going to name my variable X. And I'm going to tell my program I want to assign the value of, say, 50 into X. And let me end that with a semicolon as well. So when I refer to the value X now inside my program, it's going to know that I'm talking about the value of 50. And what I'm now going to do is I'm going to incorporate that value of X into like these values right here. So starting with this line 4. Instead of me saying 50, let me just say X. And notice that there was no change in the output of my program because the program is reading this as just 50, right? Now, for the 100, I can't just put X by itself right here. I mean, I could, but you can see that did actually change the output over here. And that's because it's now reading this as 50, whereas it was 100 from before. Now, to maintain the same relative spacing between this and that, let me do this. Let me add like an X plus 50. So when X has the value of 50, this X plus 50 is going to be 100. And so that puts that top of the car in the same location it was from before. And I can then do something similar to like this guy and this guy. Let's replace this 100 with another X plus 50. That keeps that wheel in the same place. Let's replace this 250 with X plus 200. And that, again, is going to keep that rear wheel in the same place. So, I mean, so far, what I've just done, it doesn't look any different than what I did earlier. But doing it with this variable makes it where I can now change this in just one place. Watch what happens if I set this to be 30, say. That puts the car in that position. If I increase this to, say, 50, it puts the car a little bit further to the right. If I increase this to, say, 80, it moves the car even further to the right. So I now have like one very easy point of access to modify where that car is being drawn. So yeah, is everyone with me there so far? Is that all making sense?
I'm listening. I'm trying to do it as you're doing it, but I realized I had to sign in to Khan Academy, so I had to create my account again.
Ah, gotcha. Okay. Yeah, I just use my Google account to sign in because I don't want to create like a zillion new accounts everywhere.
Right. So I'm trying.
Gotcha. Okay. But yeah, is this all making sense, like in terms of what this variable is doing and then how the variable is being involved in the drawing of these various shapes? But Marion, I think you're muted there if you were saying something.
I'm sorry, I just said I was learning. I'm just watching and observing.
Gotcha. Yeah. So that certainly works as well.
Bob, do you want to drop the code in the chat? And then people can cut and paste it into their.
Oh, yeah, sure thing. That's a good idea. Let me go ahead and copy and paste this into the chat here. Yeah, there you go. So if you're on Khan Academy yourself, you can just copy and paste that code from the chat into the environment here. And I guess let me also do a few changes to this. I'm going to move this a little bit further to the left. Let's put this at, say, 30. And let me actually move all of this down a little bit as well. So that would require that I increase all the Y values right here, right? Let me just bump all of these up by 100 pixels. So 120 becomes 220. This 70 becomes 170, and these two 200s would each become 300. There we go. So there is that car in its new position. And so where I want to go with this is you can basically just draw anything you want, just using combinations of these various draw commands that are available, as well as the colors that we have down here. The interesting stuff happens, though, when you try to animate this thing. I want to make it actually move like in real time on the screen. And I mean, essentially, all animation is you are drawing a bunch of different frames, right? And if you draw all these frames closely enough together, it kind of gives your brain the illusion that something is moving. Now, the way I'm going to set this up is the first thing is I need to define what's called a draw function. And let me see, here's the syntax for it. Okay, so don't worry too much about what all of this stuff actually means. Essentially, all this says is I am defining something called draw. And whatever I put inside this draw thing, whatever goes between these curly braces here and here, all this stuff inside is going to be repeatedly done automatically by the computer. And so if I want things to animate, I can just put stuff inside this draw section. I can somehow make that stuff inside change with every frame. And that is going to be what accomplishes this, this illusion of movement. So let me start by doing this. I'm going to copy, well, actually, I'm going to cut like all of this stuff right here, all this stuff that drew my car. And let me just put it like inside this draw function like this. And now, as a programmer, I feel compelled to indent all of this. That is not strictly required by JavaScript, but it's considered good style to do that. That makes it clear that this is within my draw function. And you can see at the moment, it seems like nothing has changed, right? Nothing is actually noticeably different in this right-hand canvas. And that's because it actually is repeatedly drawing all this stuff right now, but it's always doing the same thing every single time. And so all I'm saying is, it is repeatedly drawing this car, but every single time that car shows up in the same spot, right? Now, what I can do, though, is I can add one little extra piece of information right here. I want to tell it, the first time I do all this stuff, here's where I want to draw it. But the second time I do all this, I want to use a different value of x. I want to make x bigger so that this actually moves farther to the right. And there's one magic line that's going to do that for me. If I write x equals x plus 1, in programming, what this tells me to do is I want to compute the value of x plus 1, which would be like 30 plus 1 or 31 right now. And I'm going to take that 31 and then store that back into the variable x, which means x has now changed from 30 to 31. And once x has finished changing, it's going to come back and do all this stuff here again with a new value of x of 31. And so I should be seeing this car move to the right a little bit. Once I'm done with that, I'm going to increase x by another one. It's now going to become 32. At which point I do all this again. So the car should be moving a little bit further to the right and so on. Now, at the moment, you can see that there's this very unfriendly looking thing here. saying I'm missing a semicolon. So yeah, this is what happens when there's an error in your program. It's not going to break anything. It just like doesn't work. And it says, hey, here's what you need to do to fix it. So let me just add the semicolon and we'll see what happens with that car there. And well, it is kind of sort of moving. I mean, it is moving, actually. It's just that it's also leaving this weird trail behind it, right? Let me actually restart this to do that again. And yeah, so it is doing exactly what we thought it would. It's just that it's not doing this cleanup in the background. Now, the reason for that is every single time it's drawing this frame, it's not actually erasing what used to be there. And so all this black stuff is simply the remnants of all the previous frames that were already drawn in previous runnings of this draw function here. And there is a nice way around that. What I can do is, and let me scroll down here to find the correct command for this. There is a command for, I may have passed it actually. I'm looking for something that sets the background color. Here it is. Okay, so the command is called background, and it takes those same 3 RGB values that we saw from earlier, red, green, and blue, and that allows me to set the background color to be something. So let me do this. Let me add this background command right here at the very beginning of my draw function. And it had been white earlier, right? Now, white is going to be 255 on all 3 of these, or I could just pick white from this color picker. There we go. And what this should do is every time I do all this stuff, I'm going to start by setting the background to white first. And so that should hopefully get rid of the remnants of the old stuff. So let me try this here. I'm going to restart. And hey, that is much better. We now have this car moving cleanly across the screen. And we are not actually seeing this like trail that we had from before. So yeah, we now have some basic animation happening here. And you can do all kinds of cool stuff with this. Like at the moment, X is only changing by 1 every time. Watch what happens if I change this to say 2. What that means is the first time I run through all of this, X is 30, right? The second time, X now jumps straight to 32 as opposed to 31. And the net effect should be that we see it kind of move faster across the screen. So let me restart this. And yeah, there we go. We just kind of double the speed of our car. If I change this to say +3, then it should go even faster, right? There we go. +10, let's go kind of haywire here. And yeah, it's now zooming across the screen. Now, I can also even make it go in the other direction. I could say X equals X minus 1. And if positive X makes it go to the right, negative X should make it go to the left. So yeah, here we go. It's now kind of backing away to the other side. And again, if I were to decrease this by a larger amount, it should just do that motion, more quickly. So let's see, what else can I do with this? Let me try this. Let me try what happens if I do X times 1.01. So this, I'm not sure how this is going to work out. We'll see what happens. Okay, yeah, that is doing what I think it's going to do. Okay, so what this is doing now is X starts from 30 still, right? Every time I multiply this by 1.01, I am just very slightly increasing that 30. So, 30 times 1.01 is just barely higher than 30. But you are multiplying by 1.01 every single time. And so the bigger your number gets, the bigger that increase is going to get as well. So you can see here that the car is kind of slowly accelerating as it moves from left to right. And yeah, you can just play with all kinds of ways to modify that X value and see what effect that has on the animation. All right, so are there any questions at this point from anyone? Is this all making some good sense? And so, yeah, I mean, that's really all I wanted to show you all was just this platform for drawing and doing these basic colors and shapes and animations. I did want to show you kind of what you can do with this if you kind of go crazy with it. So there was a few years ago, I got kind of bored and I decided to make a nice animation using this system. And I have it pulled up right here. So this is kind of, out of season, since this is a very obviously Christmassy looking animation here. But I do have a nice owl who's wearing a hat with some snow falling down on the canvas, right? And what I have here is substantially more code than what I just showed you. I mean, this is about, what, almost 100 lines of code here. But it is following the same principles that I just demonstrated. There is a draw function, which is at the bottom here. And just like I showed you earlier, the first thing I do inside that draw function is I tell it to set the background to white. And that's why I'm not seeing any trails show up here. What I've done here is I've actually defined a couple of other functions as well. There's something called draw L, which actually draws the L itself. There's something called draw hat, which draws the hat up here. And if you look back a bit earlier, you can see here is my definition of draw L. So this is really just a combination of all the various tools we saw from earlier. I've got some fills of different colors for like the various shades of gray and the white and the yellow and so on. I've got some similar things here for that hat, right? So these are the shapes that make up that hat, again, with some different fill colors, etc. And then the snowflakes themselves are simply a bunch of ellipses. Now, I don't want to get into the details of how those snowflakes were implemented. I was using like arrays and some more advanced things to get that to happen. But essentially, they're simply a bunch of ellipses. Here's the ellipse command that is just drawing a bunch of those snowflakes. Now, I've also set this up to where there's a bunch of different tunable parameters here that will affect how many snowflakes and how those snowflakes move on the screen. So right now, the snow density is set to 10. That means there's 10 snowflakes. I can increase this to, say, 100. That will immediately increase the number of snowflakes I see. If I decrease this to, like, say, 1, we now just have a single snowflake there. So yeah, I can go crazy with this and say, give me 1,000 or 10,000. And the poor L is now completely covered by an avalanche there. But yeah, so that is tunable. I've also set a couple of speeds in 2 different directions, the horizontal and the vertical directions. Right now, the X speed is set to 0, which means this is moving straight down. If I set that to 1, that means it's now moving to the side as well as downward, right? If I set this to -1, it moves in the opposite direction. I can also kind of tune both this as well as the Y speed. If I make the Y speed like larger than the X speed, it will come down faster vertically than it does horizontally. So yeah, that's all tunable. Let me bring this back to the way it was, which was this. And finally, there's also a setting for randomness. So if I set this to, say, 2, I tried to simulate like an actual snowflake falling just by adding some random back and forth motion. And the higher this number is, the more back and forth motion there's going to be. So yeah, I mean, that obviously doesn't look very realistic, but for small values, I think it looks pretty decent. And then these last 2 things right here, the snow width minimum and snow width maximum, that just controls how big each one of those ellipses is. So if I want to make really small snowflakes, I could go with maybe 4 to 6 maybe. And so yeah, those are much smaller flakes, right? I could decide to make them a lot larger. So yeah, there we go. I don't know what that is now. It's more like falling snowballs than snowflakes. But yeah, everything is tunable according to the way that I wrote this code. So yeah, definitely a lot of cool stuff you can do with this platform. And I think if you search for, I'm not sure where you can find this, but there should be some way to actually look at projects that other people have done on this platform as well. And every project, you can do what's called spinning off of that project. So what that does is it basically makes a copy of that project for you in your own workspace. And you can then see exactly what code was used to generate that. You can then modify that code to do whatever it is you want it to do. And so, yeah, it is a very nice way to just kind of, learn from what other people have done. So yeah, I mean, that's really all that I had. Were there any questions or anything over this whole platform?
I do have a question if you don't mind.
Yeah, absolutely.
Okay, I went ahead and I'm on it and I drew a rectangle and
Mhm.
I drew a rounded rectangle and I adjusted it. So I've got that. Then when I go to add the color, this is what I'm not understanding. It's taking me to somebody else's drawing that already has color in it. And I don't know what I'm doing wrong.
Huh, interesting. Let me see here.
Are you clicking on color down at the bottom?
Yes, where it says,
Yep.
it says, hold on, I go to documentation and then it says fill. And then I
Oh,
click,
and then I guess you're probably clicking on that fill, right?
yes, am I wrong?
No, that's not wrong. So what that does is, yeah, it will bring up something new, but that's simply like an example of how to
Oh.
use fill.
Okay,
And so the idea is this kind of gives you an idea of just how the fill command works. And then you can play with it here if you want to just kind of experiment with the different numbers and all that.
okay,
But once you're ready to put that in your own code, just go back to the your original tab, and you would then just type in that fill before whichever shape you wanted
okay,
to
that's what I
fill.
thought, okay, thank you.
Yeah, of course. So any other questions?
Does the snow automatically come down or could you have made it go up?
Yeah, so the Y speed would control that. Right now, 1 means it is coming down at a rate of 1 pixel down per whatever the interval of the drawing is. If I do this -1, it will actually go up. So that is reducing the Y coordinate, which means it is going upward. Yeah, so I could do some crazy things here, right? I could make it go up really fast. And maybe move to the right also, or to the left rather, really fast, and have some more randomness here. Yeah, I don't know what's going on now, but yeah, we have this owl in a blizzard at this point.
When one snowflake leaves, where does the another one pop on? It pops on randomly. I see.
Yeah, I think I have a I wrote this a while ago, so I've got to read my own code here. Yeah, there's a function make new snow, which is just going to yeah, I think they just show up at some random location on the canvas. So anywhere between 1 and 400 on both the X and the Y.
Yep, I see.
And then let me also point out that there is another resource that comes to mind, which is very similar in spirit to what I just showed you all here. If you go to trinket.io, I think this is the website. And of course, it chooses now to, to not load. Murphy's Law in action. Maybe it's not trinket.io. I sworn it was trinket.io though.
What are you looking for?
It's like a kind of an interactive environment like this, but it's for Python.
Ah, okay.
Yeah, there we go. Okay, so I don't know why it wasn't loading before. But trinket.io will allow you to, yeah, here we go. So yeah, very similar setup, right? You got some code here on the left. We have what the code does on the right, or like what results from running that code on the right. And the syntax here is going to be a bit different because it's in Python instead of JavaScript. But it is also very visual. So we have like this draw circle command, which draws a circle, obviously. We can tell this turtle to like move to certain locations, change its color, make it write certain things, and so on. And so, yeah, this is another kind of similar environment, but using Python as opposed to JavaScript. All right, so any other questions or anything? So let me actually copy a link to this owls project into the chat. I'm not sure if that just works for anyone. So try going there and see if you can access this same project that I have.
Works for me.
It does work. Awesome. Okay. Yeah. So you can just feel free to mess with that, make your own spin-off or whatever if you would like to experiment with that. And see, Alistair just sent another link in the chat there to, oh, wow, Logo. That's a name I've not seen in a long time. Yeah, Logo, I think, was the inspiration behind the Python turtle. Yeah, I also remember Logo. I'm probably not too far in age from you, Alistair, but I was doing this on, this was back when they had like cartridges that you had to plug into your computer to to run a program. You know, that was the equivalent of a floppy disk back in the day.
The Commodore 64. What's your computer choice?
Oh, it was the it was a Tandy TRS-80.
Yep.
Making me feel old already.
Does anyone else have questions for Top? Well, awesome. I think we should thank him. This is really interesting. It's always nice to find these platforms where you can play online. You don't need to install anything for the students.
Yeah, exactly. Especially with the way a lot of computer systems in the classroom are locked down. So as long as you had a web browser, you know, you are good to go for these types of platforms.
Yeah, I just want to say the floppy disk, I remember trying to get my paper turned in on time on one. And I'm loving this. I'm glad that I came. I'm not a science teacher anymore. I teach ELA. And so what I'm seeing is have a child write a story and then do an animation, you know, even like with the car, just having them have it move like, okay, so where did you go? What state did you go to? I don't know. I'm just, right now my mind is just spinning. How can I use this for me? And Lord, I'm sorry. My Siri is over here doing stuff. I'm not even talking to it, but but I want to like think of a way of having a child do like an animation and like share their story with the rest of the group or something. Like even this with the snowstorm, you know, they could either like right now it's, you know, the owl, but you know, they could tell a story. It could be something maybe more they could put in the background, or even the color of the snow, or, you know, maybe they could change it to be pink snow or blue or purple. I don't know.
Oh, yeah, for sure. Right.
Yes, I mean, what grades do you teach?
I teach 5th grade.
Yeah, so Scratch is really intended for storytelling, right? Wouldn't you say, Top?
Yeah, because it has a bunch of built-in sprites, you know, with a bunch of
characters that you can move around that tell to move left, right, and right. So that's actually quite popular for sort of animating stories. It's got bats and things like that. My daughter does it for, you know, telling Halloween stories.
Oh, okay.
And there's 2 versions of it, Scratch and Scratch Junior.
Oh, I didn't know about Scratch Junior. Is that just a simplified version of Scratch?
Yes.
Yeah, I was about to text our tech person because she'll come in and do things with the kids. And I was going to ask her if she had attended this with Khan. I love Khan Academy. I've been using it for years for math and, you know, little reading videos. But oh God, this takes life to a whole nother level. Thank you for sharing.
Yeah, absolutely. My pleasure. And what is ELA again?
English Language Arts.
Yeah,
gotcha.
English Language Arts, and some people call it ILA. But yeah, ELA, English Language Arts. I teach the reading.
Scratch is intended for kids that are like 5th grade is probably fine with Scratch. Scratch Junior is intended for ages 5 to 7, so it's really the you know, K1-2 type students.
And I haven't messed with Scratch myself, but if I remember correctly, I think you can actually see the code that makes it run as well, right? I mean, the interface is all visual, of course, but there's an option to see the JavaScript behind it, I believe.
I think so. Yeah, I can have a look. It's been a long time since I played with Scratch. And unlike, I think Scratch is block based, right? Is that right? It's been a
Right.
long time since I played it. So that's the other way to have students do this sort of stuff, is rather than type stuff in, they drag around blocks of code and glue them together. We use the same gluing blocks together stuff to try and teach data science at the university. So it's a pretty powerful technique. And most of those block-based programming languages generate something that's actually regular code. And so you can switch backwards and forwards and get comfortable, and then you don't have to use the blocks anymore. So that's the other approach to doing this stuff. But Scratch is also very visual. So you can assemble stuff and then run it straight away and see what it does. And I think it's scratch.mit. Never remember.
Yeah, scratch.mit.edu probably.
Yeah.
And yeah, that's entirely web-based as well. I think there's no software installation needed at all. Yeah, it is scratch.mit.edu.
And if you look at this, you see if you click on start creating, you'll see what it looks like. So Scratch is a little cat, and then there's a bunch of ways you can make him move, way you can look, make some sounds. There's lots of stuff you can do, but it's all dragging these blocks and gluing things together to make your program.
And they've also kind of designed everything as like puzzle pieces that interlock, and so that they can only connect to each other if that makes sense for the program. So there's no way to like give it illegal instructions in that sense.
Mm-hmm.
I'm trying to remember how you even start a program here. I would have thought it'd be under control. Yes, I mean, obviously the cat is not moving right now because this move 10 steps command has not been connected to any kind of event. Oh, here we go. When the green flag is clicked, there we go. So this just says, when I click the green flag, I want the cat to move 10 steps, right? And yep, there he goes. He is moving 10 steps at a time each time I click that green flag. Or I could maybe bind this to the space key. And yeah, I'm now hitting space, and he is now waltzing up the side of the screen. And looks like they've set their XY system to be 0 at the origin, a bit more intuitive than the 0 in the upper left-hand corner.
So this is just another thing that you can play with, and it's intended for telling little stories. So you can pick a whole bunch of pre-made backgrounds, and you can make people move on them.
I remember I gave one workshop with Scratch a few years ago, and once the kids figured out the cat could make a noise, that was all I heard in the classroom was the cat making this meow sound. What is it? It's probably, yeah, probably under sound here. Here we go. Okay, so when green flag clicked, start sound meow. This might not pick up on my mic, but let's see. That was pretty loud. Did you hear that?
No, the noise suppression on Zoom takes care of it.
Okay. Yeah, that's actually a really loud meow I'm hearing from my speakers right now. And the room is just full of, 30 machines making this noise simultaneously.
You immediately switched to the JavaScript programming. It's harder to make things new.
That was the last time I used Scratch, yeah.
Well, let's thank Top for his presentation. Unless anyone has any other questions, I think that was fantastic. We're at 5 o'clock. Thank you, Top, for presenting, and thank you all for coming.
Yeah, my pleasure. And let me also put my email address into the chat here. If y'all ever have any questions, feel free to reach out. I do actually read and usually reply to my email. So yeah, kmls3@memphis.edu.
Thank you all. You all have a great evening.
All right, you as well.
Thank you. You also.
Thank you. Thank you so much.